Hello everyone, welcome back to my channel. Today we will be solving linked list cycle problem from LeetCode. So let's start with this video. We'll go through the problem description. It says, given head, the head of the linked list, determine if the linked list has a cycle in it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that post is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So basically here we need to identify a cycle in a linked list. And what do you mean by cycle in a linked list? It basically means a loop where if you keep going to the next node, you will end up reaching the same node again and again. Okay. So basically we need to return true if there is a cycle, and we need to return false if there is no cycle. So for example, here you have a single node linked list. So for this case, you will be returning false. And for the one which has cycle present in it, you will simply be returning true. Okay. So to approach this problem, I'll go to the presentation. There we will first discuss the naive approach to this problem, and then we'll see how we can optimize our solution. Okay. So let's go to the presentation mode. So here I have taken two linked lists. One is your linear linked list where there is no cycle in it, and the other one has a cycle in it. Okay. So from here we'll see how we can detect this cycle in a linked list. So the naive approach to this problem would be to identify if we have visited a node twice. So for example, let's say if we start traversing over this linked list using the head pointer, we will end up visiting these nodes again and again, right? Once we come to this loop. So if we can think of a way where we can keep a track of a visited node. So let's say if I visited this node with value 2, we will keep a track of it somewhere so that next time when we visit this node, this particular node again, then we'll be able to say that there is a loop in the linked list. And one more thing we should be keeping in mind while writing our solution is that we shouldn't be keeping track of the values, because these values can be repeated, right? For example, let's say if this node has the value 2, some other node can also have the same value. So instead of keeping a track on the value, we simply have to keep a track of entire node. Okay, so the naive approach would be to simply keep a hash map where we can store the visited node, and as soon as we visit the same node again, then we can simply check if that particular hash map has this node already present. Then we can simply say that there is a loop in the linked list. So to implement that solution, the first thing we'll require is a dummy node, right? So we'll basically initialize this dummy node with the head pointer so that we can traverse this particular linked list without losing our head pointer, because this is the only pointer using which we can access our linked list. So we'll be creating a dummy node, and then we'll be also initializing a hash map. So initially it will be empty. So from here, what we simply need to do is we simply need to check the node pointed by dummy node if that is already present in hash map. If it is not present, then we'll simply insert the node in the hash map, and then we'll move the dummy node to the next node. And again on the next node, we will check if that particular node is present. If it is not present, we'll simply put it in the hash map, and then again in the similar way we'll move to the next node, and we'll again insert the next node in the hash map as it is not present. And in the same way we'll move to the next node with value 4, and in the similar way we'll move to the node with value 5. And from here, when we go to the next node, now we see that the dummy node again reached the node with value 2, and if we check this node is already present in the hash map. That means we can simply say that there is a loop in the linked list. So yeah, that's how you can detect a linked list using a hash map. So from here, if we evaluate the time complexity, we can say that the time complexity is order of n, because as soon as we complete traversing this node, it will again come back to the already visited node, right? That means at most you will be traversing n nodes. So the time complexity would be order of n, and also as we are using hash map to store all the nodes, the space complexity also would be order of n. So now we will see how we can optimize this solution. So this solution is about having a cycle in the linked list, but the scenario where you don't have this cycle present. So in that case, your dummy node, after reaching the last node of the linked list, it will get assigned with a null value, right? So in that case, as soon as your dummy becomes null, you can say that there is no cycle present in it. So in that case, you will be returning false, right? So now we'll talk about the optimized solution to this problem. So for that, what we can do is we can simply use two pointers. We will call it a fast pointer and a slow pointer, and we will initialize both of this pointer with the head pointer. So the property of a slow pointer is that it moves only one step at a time, and the property of a fast pointer is that it always moves two steps at a time. That means whenever your slow pointer will move to the next node, the fast pointer will move to the next node. That means it will move two steps when slow moves one step. Okay. So in this way, we will simply move both of this pointer, and we will keep moving this pointer until these two pointers meet again. So I'll show you what I mean by that. So in the first iteration, slow pointer will come to this node, whereas the fast pointer will come to this node. So if you see, so after first iteration, the slow pointer is pointing to the node with value 2, whereas the fast pointer is pointing to the node with value 3. In iteration 2, the slow pointer will come to the node with value 3, and the fast pointer will come to the node with value 5. Similarly, in the next iteration, slow will come to the node with value 4, and fast will come to the node with value 3. And from here, the slow pointer will go to the node with value 5 and the fast pointer will also move to the node with value 5. Now at this point, we'll see if slow and fast pointer are pointing to the same node. That means we can simply say that there is a cycle present in a linked list. So from here, you can simply return true in this case. Whereas, let's say if there is no cycle present in this linked list. So in that case, the fast pointer will reach to the end of the linked list. So for that, what you need to do is you simply need to check if this fast pointer is pointing to the last node. So you can simply check if the node.next is null. That means it is at the last node. Or you can check if fast is pointing to the second last node, right? By doing fast.next equal to null, right? So in that way, you can simply check if there is a cycle present in it or not, right? So now you must be thinking, what is the intuition behind this solution? So let me tell you that whenever there is a cycle present in the linked list, you will always have a scenario where your fast pointer will be just behind the slow pointer. So whenever there is a loop around which this fast and slow pointer are moving, then obviously there will be a time where the fast pointer will reach just behind the slow pointer. And after this point, as soon as the slow pointer will go to the next node, the fast pointer will reach the same node by moving 2 steps, right? So to understand the intuition better, what I would suggest is try out with different linked list size and then keep your pointers at different positions and have a loop and keep rotating these 2 pointers. You will see that you will always get a scenario where your fast pointer will always reach just behind the slow pointer. And just after that, in the next iteration, both pointer will meet at some node. So you can try out that. So now it's the time we'll talk about the time complexity over here. So here the time complexity is order of n because we are moving both slow and fast pointers simultaneously. And also as we are not using any extra space, we can say that the space complexity is order of 1. Now we will see some demo code in Java and C++. So for that, I'll go to the LeetCode website. So here if you see, we already have a editor attached to this website. So here we will see the Java solution first. So here I've already written the function. So here is the function written where we have this function has cycle and it has the head node in the parameter. So the first thing we are checking if the head is null. If it is an empty linked list, we'll simply return false. Or if head.next is null, that means if it is a single node linked list, we can simply say that there is no cycle in it, right? After this check, what we are doing is we are creating fast and slow pointers, right? As I mentioned in the presentation, but we will be having 2 pointers, fast and slow. We will assign it with the head node and then we'll keep moving the slow pointer by 1 step and fast pointer by 2 steps until your fast reaches the last node or the second last node. And during this iteration, we will be checking if fast equal to slow. That means if both this pointer pointing to the same node, we can simply return true. That means there is a cycle present in the linked list. Otherwise, if this while loop ends, we can simply return false by stating that there is no cycle present in the linked list, right? So this is about the Java solution. Now next we'll see the C++. It is very similar to the Java solution. So here we have this function has cycle, which has this head pointer in the parameter. So the first thing we'll check if head equal to null. That means if it is a empty list, then we'll simply return false. Or if it is a single node list, then we'll simply return false. Under these 2 conditions, you do not have a cycle present in it, right? And after that, we will simply create 2 pointers, fast and slow, and we'll assign it with the head node. And then we'll simply move the slow pointer by 1 step and the fast pointer by 2 steps until your fast pointer reach the last node or the second last node, right? And during this iteration, we simply check if fast equal to slow. That means if both the pointers pointing to the same node, that means we know there is a cycle present in the list and we need to return true. Otherwise, if this while loop ends, we simply return false by stating that there is no cycle present in the linked list. So yeah, that's all about the C++ solution. I hope the problem and the solution is clear to you. If you have any doubt or any suggestions, you can write it in the comment section. That's all about this video. If you learned something from this video, please hit the like button. And if you're new to this channel, please don't forget to hit the subscribe button and press that bell icon so that you get notified for our upcoming new videos. Thank you for watching.